right, cool. Let's get started then. Hopefully you've gotten down at least the first steps in the first box. Okay, so with multiplication, this is it's quite fun because what you don't have to worry about anymore is finding common factors. Okay, that is the most important thing. Multiplication is easy. Adding and subtracting is more difficult. Okay, so you have to pay very special attention to what you're being asked to do. Okay, clearly, right? I'm telling you to multiply, but what you're primarily looking for is what is the sign that separates both of those rational expressions. Okay, because if it's multiplication, it's a very simple process, right? If it's adding and subtracting, then you have to find those factors that are going to give you a common denominator. With multiplication, you do not need common denominators to get started. All right, so here's kind of like the first thing. The first thing is, well, looking back at our steps, is to make sure that the numerator and denominators are completely factored. Well, because we have a bunch of monomials, well, we can assume that these are already in a factored format. The second part is let's first identify excluded values. And excluded values goes back to those first two lessons that we looked at the beginning of the year, not the year, but the beginning of the unit. Right, so in my denominator, the only variable I see is 7n. So that's the only one that's going to create issues in terms of excluded value. So I'm just going to highlight this for now because this is what I want to set equal to 0. 7n equals 0. If I divide both sides by 7, then I know that n is equal to 0. So I have an excluded value here of 0. Okay, and now that we have the excluded value out of the way, we can just keep going now with the algebra to simplify this expression. Okay, so there's many ways to do it. You can treat any factor in the denominator as something that can simplify with any factor in the numerator. So here's what I mean. For example, even though I have n to the third in the top left and a 7n in the bottom right, because 7n is part of the denominator and it's going to be a product of the denominators, what I can do is start looking at this and saying, well, this n can cancel out with one of the n's up here in the numerator because that's going to bring me down to n squared. Okay? So now I've taken n to the third, divided it by n, and I'm left with just n squared, and the n in the denominator is gone. Something else I can do is I can start to simplify here, look for factors that are fractions that can be simplified. So 6 and 4, they both have a factor of 2 that we can divide out. So if we divide this by 2, we get 3. We divide this by 2, we get 2. Okay, so now, once I've simplified pretty much everything, because now 9 and 7 can't be simplified, 9 and 2 can't be simplified, 3 and 7 can't be simplified. What I'm left with now is just 3n squared times 9, right? So let me just kind of rewrite it in a cleaner way. 3n squared all over 2 times 9 over 7, right? Because the n is gone now since we canceled that out. So then what you can do is multiply your coefficients. You can multiply 3 times 9 to get 27n squared all over 14. Okay? And that's it. Right? That's pretty much it. The reason why I've simplified the values before is because it becomes harder to multiply things across when the numbers are large, right? Like we also could have done, let's say, for example, I chose not to simplify anything. Let me show you a different way. Let's say I choose not to simplify anything at first, and I just multiply straight across. Then let's say now I would get, what, 54 n to the third all over 28n, right? This is another approach. You can see that n to the third over n is going to cancel out one of them, so you're going to be left with n squared. Meanwhile, this n is gone. But then you have to look for, well, what numbers can divide 54 and 28, right? And you might think, okay, well, at least 2 can divide those. So if you divide the top by 2, you're left with 27. You divide the bottom by 2, you're left with 14. Ultimately, still, you're going to get the same final expression, right? This is the most simplified form, which is the same thing that we got here, right? So 2 different ways to approach it. You can multiply everything across first and then simplify after, or you can start to kind of chip away at it as you go and kind of work with smaller numbers. It's ultimately up to you and how you prefer to do it, okay? But either way, it could be correct, okay? So make sure that you list the excluded value and then you box in your final simplified expression, okay? Any questions on that part so far? No? Okay. All right, let's move on. Okay, let's add a little bit of a complexity here. Here is what I mean about we are not looking to expand. We're not looking to FOIL anything, okay? Here, all we're trying to do is just find a way to multiply across in the simplest way possible, all right? So first off, let's take a look at what the excluded values could be for our denominators, okay? Well, since one of my excluded values comes from here, having an n minus 4 as a denominator, and the other one would come from 4n squared as being part of the denominator as well. Okay, now the reason why I don't need the other n minus 4 is because it's the same number, right? So I don't need to solve n minus 4 twice. I can just do it once. So let's set that up real quick. N minus 4 equals 0, and then 4n squared equals 0. Right, so when you solve for n will equal 4. 4 will be an excluded value. Here, when you solve for n, you can divide both sides by 4, and you're left with n squared is equal to 0. If you square root n squared, n will equal 0. So then the only two values here that will give you that are excluded are 4 and 0, okay? So now that we know that, we can then go ahead and move on with the algebra part. Okay, so in this case, here's what I'm gonna do, okay? Again, different strategies can be used in different scenarios. In this case, I'm gonna try the strategy where I kind of combine everything together and then I cancel once I've done that, okay? I think it'll be a little bit easier than if I do it by pieces. So if I notice in my numerator, I have n minus 4 squared, and then here n minus 5, if there's no parentheses, put the parentheses around it so that it helps focus that this is a factor, right? So what you can write it as is n minus 4 squared times n minus 5. Okay, again, you do not need to expand this out. Do not expand it out, because what we're trying to do is eventually simplify it by canceling items out, canceling factors. If you expand it out, then at the end, you're gonna have to factor it back. And then you're gonna have to then cancel, right? So you're gonna do double the work that you don't need to do. In the denominator, you have 4n squared. Again, we're not gonna FOIL that into the n minus 4, but because I have n minus 4 times another n minus 4, I can see that then that can become condensed as n minus 4 to the second power. Do you guys see that? Okay, I know you guys are shy, but please talk to me. Tell me yes or no. Thumbs up works too. Yes. All right. Awesome. Thank you. Okay. So now, do you see why I chose this time to kind of condense everything? Because now what I see is I have an n minus 4 to the second power divided by another n minus 4 to the second power. So guess what happens with those n minus 4 to the second powers? Those factors will divide out, right? They're completely gone. So then what we can bring down now is just n minus 5 all over 4n squared. And then that's our final expression there. Okay, there's not much more we can do to simplify that. Okay. All right, so let's move on now. That one was pretty easy, nice and fun. All right, let's take a look at the next one. Okay, right. So this is where if if somebody jumps on, tries to do a problem without watching the lesson, they're probably going to try to FOIL this stuff out, right? And it's going to be a huge mess, and it's not necessary. Okay, what we're trying to do is first factor everything in the numerator and the denominator. So let's start with the first fraction. Okay, we have n plus 2, so I'm going to bring this down as n plus 2. In my denominator, okay, I can see that this was going to break into two factors because it's a trinomial. I'm looking for factors of -8 that add up to be -2. So I believe here we're going to have an n minus 4 with an n plus 2. Okay, and I'm going to put n plus 2 here in parentheses. Okay, times the other fraction. Okay, in the numerator, we're going to have to do some factoring there. We're looking for factors of 12 that add up to be 7. So I believe we can use 4 and 3. So n plus 4 and n plus 3. Denominator, again, another set of factors. N squared, we know that's n times n. And then in order for it to multiply to be -15, but add up to be -2, that's going to be a -5 with a +3. Okay? All right, so at this point, notice how everything in the denominator has kind of been listed out for you, right? So you're going to have 4 possible excluded values there, because each one of those, there's a specific value that could turn the whole denominator into a 0, especially because it's a product. So then you have to then obviously split this up into those 4 different possibilities to find those excluded values. So you have n minus 4 equals 0, n plus 2 equals 0, n minus 5 is 0, and n plus 3 is 0. Right, so let's just go ahead and solve. We'll find our 4 different excluded values. We know n will be 4. Here, n will be a -2. Here, n will be 5. And here, n will equal a -3. Okay, so for our excluded values, we have 4, -2, 5, and -3. Okay, all right. Now that we've gotten that out of the way, let's go ahead and combine everything in the numerator, everything in the denominator, and then we'll just go through and divide everything out. Okay, so in my numerator, again, do not FOIL, just kind of push them all together when you multiply. So you have n plus 2 times n plus 4 times n plus 3 all over n minus 4, n plus 2, n minus 5, and n plus 3. Okay. All right, so now you can tell I have a lot of factors here that can cancel out for us. So one of those is going to be the n plus 2 with the n plus 2. That's gone. Okay. The other one will be n plus 3 and n plus 3, and that's gone. Right? Now, n plus 4 and n minus 4, they don't cancel, right? Because they're not the same factor. So be careful not to cancel those out on an accident, I'm sorry. And you would just be left with n plus 4 all over n minus 4 times n minus 5. Again, do not FOIL those in. You can leave the answer the way it is. That is perfectly fine. Don't waste time FOILing in and then maybe potentially making a mistake. Okay, so that would be our final expression there for this example. Okay, so you want to factor and leave things in factored format. Okay, it's the best way to approach these types of problems. Okay, any questions on this so far? How are we doing? Do we feel okay? It's not too bad, right? We're good, okay. Sounds good, good. Okay, all right. Yeah, I think, is it possible for no excluded values to exist? Yes, very possible for no excluded values to exist. Let me show you, Selena. So let's say, for example, what if this n had never been there in the first place? Right? When there's no variable in the denominator, there's no possibility for excluded value. The only time you would have excluded values is when you have a denominator, I'm sorry, a variable in the denominator. Okay, that's the only time. So yeah, that's a good question. So it is possible. All right. All right, let's keep going. Okay. Okay, so now, again, similar, right? Let's start with the left. Let's factor. Here, 6x plus 60. Again, this is a product between 2 different fractions. So here between 6x and 60, it looks like 6 could be the GCF, so we can factor out a 6, and we're left with 6 times x plus 10 all over x minus 3. Okay, that's our factor. Okay, times, now we got to do a little bit of factoring on the other side. Okay, we're looking for products of 27 that add up to be -12. What do you think those numbers could be? Mm, 9 and 3? Yeah, okay, we could do 9 and 3. What would the signs for those numbers be? Remember, it's multiplying to be positive, but adding up to be negative. Yeah. Yeah, if you had 2 negatives, right? They multiply to be positive 27, they add up to be -12, right? So that's good. Okay, all right, now let's look at the denominator. Okay, same idea here. We have an x with an x. They need to multiply to be positive 54, but add up to be -15. What do you think those factors could be this time? Yeah, we have a 9 and a 6 this time. And again, it's a similar scenario because they're multiplying to be positive. So we have a -9 with a -6. Okay, so everything's factored out. Let's get our excluded values out of the way. We have 3 potential factors that could give us zeros. So let's list them out. X minus 3 equal to 0. X minus 9 equal to 0. X minus 6 equal to 0. Okay, so in this case, our excluded values would be 3. Here would be 9. Here would be 6, right? If you were to plug in a 6 into those x values in the denominator, you would get 6 minus 6, which would make everything 0, because it'd be 0 times whatever, it's still 0. Okay, so then our excluded values are 3, 9, and 6. Okay, so now moving across, let's push everything together and then we can cancel out whatever is needed. All right, so we have 6 times x plus 10 times x minus 9 times x minus 3 all over x minus 3 times x minus 9 times x minus 6. Okay, so our factors will be x minus 3 over x minus 3. Those are divisible. X minus 9 over x minus 9, those are divisible, right? So then finally what we're left with is simply a 6 times x plus 10 all over x minus 6, okay? And then since we can't divide those factors out, we're just gonna leave it that way, that's okay. That is our simplified expression right there. All right. Any questions so far? How are we doing? Thumbs up, all right. That's good. Okay, now let's focus on division. When we do division, we're not gonna focus on the excluded values. Let's just focus on kind of like getting the process down for now, at least with division. Okay, so here's a scenario where, again, pay attention to what is being asked of you, right? If it's being asked for division, you are going to do something called keep, change, and flip, which means you're going to keep the first fraction the way it is as 5 over 8. You're going to change the division into multiplication, right? So now it's a product instead. And then you're going to flip the second fraction. So you flip it and you make it 4 over 5m. Okay. Now it's a multiplication problem. You just move straight across, you multiply. Okay, so in a problem like this, I'm going to try to do a little bit of a reduction. Right, I have a 5 and a 5. This 5 would cancel. This 5 becomes a 1. Right, so we just have 1 in that numerator spot. Over here between the 4 and the 8, the 4, if you divide by 4, you're left with 1. If you divide this by 4, you're left with 2. Okay, so really, what is it that you have? Well, you have in the numerator 1 times 1, which is 1. In the denominator, you have 2 times m, which is just 2m. Okay, and that's it. So pretty easy, same idea, but you want to use a keep, change, flip strategy with division, okay? In this case, we didn't have to do any factoring because everything was a monomial. So it was pretty easy, right? But if we had to, we would just do this factoring first, then we can keep, change, and flip. And then after that, we do our cancellations, okay? So not too bad. All right, let's move on. Next one here. Okay, so here's an idea, right? Here's something similar. Again, we're doing division, so you're going to want to do a keep, change, flip. nothing is, or I'm saying everything is factored at this point, right? So I think we're okay. All right, I think we're okay. So now let's see. Let's keep change and flip. All right, let's see what we can get. So we have n plus 2. Again, it's not in parentheses, but I'm going to put them in there anyway. Divided by 3m, m plus 2. Okay, times, now we do the flip. Okay, m plus 9 times m minus 2 all over 2 minus m. Okay, I'm going to put that in parentheses. Okay, so maybe even before I start trying to go across, look at the first fraction. I have an m plus 2 over m plus 2. Okay, those right there can be simplified and divided out, right? It eliminates something that then I don't have to worry about later on in the problem, right? So the m plus 2s are gone. If there's nothing left over in the numerator, there is at least a 1 there. Okay, so you at least have 1, the number 1. Okay, all right, so now in the other fraction, take a look. I have m minus 2 and 2 minus m, right? This is something that we've kind of seen before. This is potentially something that maybe we can factor something out to get them to look the same. Do you guys remember what it is that would need to be factored out of maybe the bottom 2 minus m there to get it to look like m minus 2? What would we have to factor out? Yeah, the negative, right? We'd have to factor out the negative. So in this case, let me rewrite some stuff here. So I would have 1 over 3m times m plus 9, m minus 2. Okay, but my denominator now, if I factor out this negative, let me do some scratch work here. If I factor out a negative, it's going to leave me with negative 2 plus m. Okay, but negative 2 plus m could then just be rewritten so that you have m minus 2 with the negative outside. Okay, so you just kind of flip the order of the m and the minus 2. Okay, so now I can just, instead of writing 2 minus m, it's the same as the negative m minus 2. Okay, and so then what we can do is we can now cancel the m minus 2 with the m minus 2. The negative still stays though, okay? So just be aware that you do have a negative in the denominator. Okay, so now if you multiply across, the only thing in the numerator now is 1 times n plus 9, so it's just m plus 9. And in the denominator, 3m times a negative is just a negative 3m. Okay, so then there you go. That's your final expression there. Any questions on that so far? No? Okay. All right. We're good so far. Okay, here's another one similar, right? Okay, so you have 4b times b plus 10 all over b plus 10 to the second power divided by 1 over b plus 10. Okay, so let's start here with this first one, 4b b plus 10 times b plus 10 to the second power. We're being asked to divide, so we're going to change this to a product, and then we're going to flip the second fraction. So we get b plus 10 all over 1. Okay, now if you were to multiply across, you would have 4b times b plus 10 times another b plus 10. So those two b plus 10s that you have, these two, you can just condense them because you're going to have b plus 10 to the second power. All right, so you can write it as 4b times b plus 10 power of 2. Okay, your denominator in this case, it's only going to be b plus 10 power of 2. So what's going to happen? In this case, those will divide out completely. And now you're just left with 4b as your final expression, right? There's nothing left in the denominator. There's only a 1, but 4b over 1 is the same thing as 4b. So you can just leave it as 4b. Okay, any questions on that one so far? All right, seems like we're okay. All right, last couple. All right, so here, same idea, right? Let's start with x plus 2. Bring that down all over 6x. Okay, 6x is a monomial. There's nothing to really factor out of that at the moment, so we're just going to leave it at 6x. All right, divided by, okay, so we're going to want to do a product, and then we're going to flip, right? So now it's 6x squared minus 54x all over x plus 2. Okay, so I'm going to wrap some factors in parentheses. I have 6x squared minus 54x, right? That's not factored. So I would need to factor that first before I go any further, okay? So what we can do now is say, all right, well, this is still going to give us x plus 2 over 6x times, look at the two factors in my numerator there on that second fraction. What looks like it can be factored out of 6x squared minus 54x? What do you guys think? Yeah, we can definitely factor out a 6. What else do they have in common that can be factored out of that numerator? Yeah, the x, right? So we have 6x that can be factored. So if we factor out 6x, that leaves x minus 9, right? All over x plus 2. Okay? So if we really wanted to push everything together first, we can, and we can say, okay, well, here the product of numerators is going to be 6x times x plus 2 times x minus 9 all over the product of my denominators, which is again 6x times x plus 2. Once again, I have a pair of divisible factors in the numerator and denominator. Let's start with the x plus 2. That's gone. Okay, I can divide out 6 over 6, and then x over x also divides out. Right? So eventually, we're just left with the x minus 9 as our final expression there. Any questions on that one? All right, guess we're okay. Okay, now the last one, a lot of factoring that needs to take place, right? Because we have 4 different trinomials, all right? So we can do this though, shouldn't be too bad. Let's start by factoring first before we go into the keep, change, flip process, just so we can clean this up, right? So I wanna start by factoring everything first. And again, you notice how like sometimes I've flipped first and then I factor, or I factor first and then I flip. Again, it just kind of depends on the problem. Like sometimes when I see something and it's so overwhelming, I want to just try to factor it first, because maybe there are factors that can be canceled out within the same fraction, right? So maybe it's possible. Okay, so looking at this one here, what we want to see is, okay, I can factor that into 2 factors. It's a trinomial, so we have k times k. The factors of 72 that would add up to be 1, probably 8 and 9, key, or 9 and 8. Let's see, the larger factor has to be positive because it adds up to be positive 1. So I think that means positive 9 with a negative 8. Okay. All right, denominator now. I have k times k. Multiplies to be negative 63, but adds up to be a positive 2. Okay, so factors of 63. probably 9 and 7. Right? It's adding up to be positive 2, so that leads me to believe that the larger factor is positive and the smaller factor is a negative. Okay, so here, right, 9 times negative 7 would be negative 63, but 9 plus negative 7 or 9 minus 7 is 2, right? So that seems like it makes sense. And this is kind of what I was mentioning, right? By factoring it first, I'm able to notice that k plus 9 over k plus 9, those factors are divisible, so I could just get rid of them right away, right? So really, I'm just dealing with k minus 8 over k minus 8, okay? All right, I'm not gonna do the flip yet. I'm gonna keep the division sign because I wanna focus on factoring first. My numerator, again, another trinomial, we wanna factor it into k times k. Factors that multiply to be 35, I believe we can do 7 and 5 here. Because it adds up to be positive 2, that means the 7 is the larger one. So 7 times negative 5, negative 35, but 7 minus 5 is 2, so that seems like it works. Okay, denominator. All right, first of all, there's a leading coefficient here that's negative. So first of all, let's factor out that negative, which will turn this into k squared minus 12k plus 35, right? So when you factor it one more time, you bring the negative down, and now you can factor this into two factors, right? So you eliminated that negative coefficient from the front, and hopefully it makes the factoring a little bit easier for you. All right, this time, we want the factors to multiply to be positive 35, but add up to be negative 12. So I think it's the same numbers, k and 7, k and 5, except this time, if it's going to multiply to be positive, they both have to be negative, and then that allows them to add up to be negative 12. Okay, so I believe we're on the right track now. Okay, so again, take a look. K minus 5 over k minus 5, that's gone, right? Those are gone. So really what's left? You have k minus 8 over k minus 7 divided by, at this point, if you want to make the change, okay, now you can change that to a product. And then you can flip, right? Flip whatever's left over for you on the other fraction. So if that negative k minus 7 was in the denominator, bring it up to the numerator. And then you bring down k plus 7. Okay. All right. Again, don't distribute that negative in, because if you do, you're going to kind of lose the ability to cancel out those k minus 7s. Okay. So just kind of condense it, bring it together. You have negative k minus 7 over k minus 8 all over k minus 7 times k plus 7. Okay, so once again here, k minus 7 cancels out with k minus 7. And you would be left with a negative k minus 8 all over k plus 7. And there is your final expression. And I believe we're done. Yeah, that's our last example. Okay. So there it is, multiplying and dividing rational, I was going to say fractional, but rational expressions. Not too bad. I believe much easier than adding and subtracting, but you have to remember what you're doing depending on the sign. Okay, I've seen many mistakes before where people see the multiplication sign, but yet they still try to get common denominators, and that's not necessary. Okay, so multiplication, you factor, you move across, you multiply across, and then you can divide out. And then if it was adding and subtracting, you got to get those common denominators first. Okay, so very big ideas, right? They look similar though, so easily mistaken. All right, because I've seen it before. I've seen the mistakes happen before. All right, good. I'm glad, Jesus. I'm glad you get it.